right, welcome to week 3. This will be the last week of this course that we do only math-based things. Okay, I know for the first 3 weeks it seemed like this is a math class, not chemistry, but we do so much algebra in chemistry that we kind of have to start with that to like lay the foundation of how we do math in chemistry. So this will be the last week that we actually do only math, and then we'll get into more of the real chemistry next week, okay? But this week we are going to talk about significant figures. It's kind of the bane of every sophomore chemistry student's existence. If you think to all of like your algebra classes, if you're doing like a word problem and you're trying to calculate something, an answer, and it'll always say in that word problem, round your answers to the blank, to the nearest whole number, or tenths or hundredths, right? But it's kind of arbitrary. So in chemistry, we use significant figures to tell us how to round calculated answers, okay? So in chemistry, if you're going to use any measured value, right? Like you measure a length of an object. If you're going to use that length in a calculation, then the answer or the outcome to that calculation cannot be more precise than your original measured value, okay? So you can't measure a value that's like 12 centimeters, right? And then use that value in a calculation and end up getting, 14.888 centimeters, right? This is a whole number of centimeters. This is to the thousandth of a centimeter, right? So you can't increase the precision of your measured value simply through calculations. So that's why we have to do significant figures. And they're really important in all of the calculations that we do in chemistry. But for this lecture, I'm just going to teach you first how we count significant figures in a number, and then how we round to a correct amount of significant figures in a number, okay? So let's start first with counting sig figs. Okay, I'm going to use SF as significant figures just because it's a pain to keep writing out. So whenever you see SFs, that's just significant figures, okay? So first, just counting sig figs. Now there's a couple rules that we have to know when we're counting sig figs, so we'll start with the easy rules, and then it'll get a little more tricky as we go along, okay? But the first one is that all non-zero numbers are significant. Okay, all non-zero numbers are significant. So if we have, for example, the number 835, if I asked you how many significant figures were in that number, it would be all non-zeros are significant. So we have 3 numbers in 835 that are not 0, and so therefore this would have 3 significant figures, right? Because there's 3 different digits that are not 0, okay? If we had 921.44, you look at that number, there are 5 digits in that number that are not 0. So here we would have 5 sig figs, okay? So that's the easy one, right? Anything that is not 0, automatically significant. The tricky part comes when we're talking about zeros, okay? Now we have 3 different types of zeros that we have to worry about. Again, we'll start with the easy ones and then get a little trickier, okay? So the first one, the first type of zero is what I'm going to call a middle zero, okay? And as the name implies, where do you think these zeros are located in a number? Great, they're in the middle. So these are located in between non-zero numbers, okay, located in between non-zero numbers. For instance, if we had 503, all right, see how this 0 is in between non-zero numbers? That's what we call middle zero. Any 0 that is in between two non-zero numbers are always significant. Okay, so any middle 0 is automatically significant. So if we apply these first two rules to this number, 503, well, all non-zero numbers are significant. So, of course, the 5 is significant and the 3 is significant. But also we have a middle 0 here, so that middle 0 is going to be significant, meaning we have 3 sig figs in 503. Okay? How about this one? We have 143,009. Okay? Now, here we have two zeros back to back, but all we care about is that eventually they are kind of bookended by two non-zero numbers. It doesn't matter that there's two in a row, it just matters that eventually they are capped by two non-zero numbers. Therefore, they're considered middle zeros, and we would have 1, 2, 3, 4, 5, 6 significant figures. Okay? So that's the first type of zero, if they're in the middle. The second type are leading zeros. Okay, so we have middle zeros in the middle, now we have leading zeros. These are obviously out front of non-zero numbers. So in front of non-zero numbers. Maybe you can think to yourself, how would you get a 0 out front of a non-zero digit? Maybe you can think it's only going to happen in a decimal, right? So if you have something like 0.00432, see how these zeros are out front of non-zero numbers? It turns out that if you have zeros out front, these are never significant. Okay, middle zeros are always significant, leading zeros are never significant. So 0.00432, this is not significant, not significant, not significant, and then 4, 3, and 2 are all significant. So this would be 3 sig figs. Okay, how about this? 0.000850003. It's a big ugly number, but if you just look at this number, we have all of these leading zeros out front. Those are never significant. Okay, so no, 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 no. We have an 8, that's non-zero, 5, non-zero, but then we come to 2 more zeros. Hopefully you can just tell what type of zeros they are. Those are middle zeros because they're in between the non-zero digits, so they are significant as well as that 3. So leading zero is not, then we have 5 significant figures afterwards, so we would have 5 significant figures total. Okay? And then we come to our last type of zero. So we have middle zeros, leading zeros. Maybe you can guess what this one's going to be. Whoops. And I call them trailing zeros. Okay? So these trailing zeros are just zeros that are located after non-zero numbers. Okay? Now, let's put an example here. Let's just do something like 1500, right? So we have zeros that are after non-zero numbers. Middle zeros are always significant. Leading zeros are never significant. This one's going to be our sometimes significant, okay? So So this is sometimes significant. But it's pretty easy what it depends on, okay? The only thing that dictates whether trailing zeros are significant or not is a decimal point. If there is a decimal point anywhere in the number, then all of your trailing zeros automatically become significant, okay? So all you have to do is ask yourself, is there a decimal? If the answer is yes, then it's significant. If your answer is no, then your zeros are not significant. Okay, so 1500, as we have it written here, 1500 would have 1, 2, but not those zeros significant, so we would only have 2 sig figs. But can you think, okay, if a decimal makes a trailing zero significant, how could we make the number 1500 have 4 sig figs, but not change the number? If we still want it to be 1500, what could we do to this number to make those zeros significant? Great, all you have to do is add a decimal, right? So that doesn't change the value of the number. It's still 1500, but now you have 1, 2, 3, 4 sig figs simply because there is a decimal point, okay? So those are all the rules. Let's just see if we can do a couple to apply all of these rules. So I will erase here, and we'll just do a couple examples at the top here. So let's try 1509.60, okay? So looking at those numbers and your rules, we have a 1, a 5, a 9, and a 6 that are really easy. We can say that they're significant right off the bat because they're not 0. But then, what type of 0 is this? It's in the middle, so it's going to be a middle 0 and it's significant. And then this 0 is a trailing 0. So all we have to do is ask ourselves, is there a decimal somewhere in the number? The answer is yes. So that would also be significant, and we would end up having 6 significant figures. Okay? Let's do one more, and then we'll go on to rounding. Let's do 0.00624040. Okay, it's a long, ugly number, but let's figure out what we've got. First of all, non-zero numbers, always significant, so we got 3 of those. We'll come to the first zeros here out front. Those are leading, and they are never significant, so we don't count those. Next one we come to is in the middle. It's a middle 0, which is always significant, so we'll count that. And then the last one here we come to is a trailing 0. We ask ourselves, is there a decimal? The answer is yes, so that is significant, and we would have a total of 5 sig figs. Okay? Okay, so it's really important for you to remember that we are going to have to worry about sig figs when we do any calculation in chemistry, okay? Anytime. Because if you think about it, you know when you plug in numbers into your calculator and you hit enter and sometimes it gives you an answer that's just this big, long, ugly decimal? Well, we're not going to be able to report that exact number that your calculator spits out to you as your answer because, again, we can't increase the precision of the answer compared to the numbers, the measured values that you used for your calculation. So what we're going to have to do is we're going to have to take that long, ugly number that your calculator gives you and round it to a correct number of sig figs. So I want to talk about how we are going to round. And this isn't that difficult, but I just want to make sure we're all on the same page. Okay? So let's say you plug in your numbers for your calculation, and the calculator gives you this gross number, 130.90415.6. Okay, something gross like that. Now, if we had to just figure out how many sig figs are in this number, that would be pretty simple. Right? Non-zero numbers, easy. These zeros are both considered good, middle zeros, so they would be significant also. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9 sig figs that our calculator is giving us. Okay? So 9 sig figs. But then let's just say that we're not allowed to have 9 sig figs because the rules for calculations with sig figs tells us you can actually only have, 7 sig figs. So we're going to have to round this to 7 significant figures. Okay, so let's see how we do that. We have 9, we can only be allowed 7. So what we're going to have to do is just start counting our sig figs from the left and go to the right. So you can kind of do this in your head once you get good at it, but I'll just show you what we do here. So I'm going to just label each number from left to right, labeling which significant figure they are in this number. Okay, so we have 1 through 9. And all we have to do is round it to 7 sig figs. So we look at our 7th sig fig. We're going to put a little bar right there so we know where we're trying to cut it off. And then all you do is take the number to the right of it, figure out if that number will round this previous number up or keep it the same, and then just rewrite the number. So this one's pretty easy. Is that 5 going to keep this one a 1, or is it going to round it up to a 2? It's going to round it up to a 2. So for 7 sig figs, this becomes 130.9042. Okay, we've just rounded it to the correct amount of sig figs. Now, 7 sig figs is still a lot, so let's keep going. Let's say we only want, 4 sig figs. Let's say we want 4. So I'll erase this. And now we need 4, so I'll put this bar in between the 4th and the 5th sig fig, and our answer with 4 sig figs just becomes 130.9. Still pretty easy, okay? Now let's do one more, and it's a little trickier, okay? Let's try and take this number to 2 sig figs. Okay, so again, look at our original number. I'm going to put a bar in between the 2nd and the 3rd sig fig. And so you do the same thing. Does this 0 round the 3 up or keep it as 0? Obviously, it's going to keep it as 0. But a lot of kids just want to say, okay, 13, right? We changed it to 2 sig figs. But do you see how if you round 130.904156 to 13, it doesn't really make sense, right? You're completely changing the number when all we really want to do is round it to the correct number of sig figs. So instead of 13, all you need to do, because it is 130, we're going to keep it 130, but not put a decimal at the end, right? Because that would make the 0 significant. If there's not a decimal point, it's not significant. So that's 2 sig figs. Yes, yes, no. But it doesn't change the value of the number. Okay? So one more quick example kind of like that, because this is the tricky part. Let's say if you had 1540.8. Okay? Now that is 5 sig figs. It's a 0 in the middle, so it's significant. 5 sig figs. But let's say again we only are allowed to have 2 sig figs. Well, we'll put our little bar in between the second and the third significant figure. That 4 is going to keep the 5 a 5, right? So we'll put 1, 5. But again, we can't round 1540.8 to 15. You have to add insignificant zeros there so it doesn't change the value of the number. It doesn't change the digit, the column that the digit is in, right? Like, see how this 5 is in the hundreds column? This 1 is in the thousands column. So we can't change the column that the digit is in. The 1 is still now in the thousands, the 5 is still now in the hundreds. If we just kept it 15, the 5 would be in the ones column and the 1 would be in the tens column. So you would be changing the column that the digit is in. Don't do that. Just add insignificant zeros so that the digits stay in the same columns. All right, that's it.